Started. Number 1 in the coordinate proof homework sheet says the points A, which are 2, 1, B, which is 6, 3, C, which is 8, 7, and D, which is 4, 5, are the vertices of a quadrilateral. Seems simple enough. Let's graph that. 4, 6, 3. Then 8, 1, 2, 3, 4, 5, 6, 7. I actually have to go a bit out here. 4, 1, 2, 3, 4, 5. Let's connect that with red. The graph is a little out, but that point right here, this is actually C, so yx if you want to. B at C. I don't even need to write C. It was just conveniently located over there. So is this a rhombus? Is this a rhombus? Well, first, before we figure out if it's a rhombus, we need to find out if it's a parallelogram. This is kind of like the hierarchy of quadrilaterals. First you have a quadrilateral that's separated into trapezoids and parallelograms, and these parallelograms can be rhombuses or rectangles, but both of them make up a square. So if we want to prove it's a rhombus, we need to prove it's a parallelogram first, because the line of order goes that way. So one of the most popular ways of proving that something's a parallelogram is through the slope method. If both pairs are parallel, then both pairs of opposite sides, if they're parallel, then this figure is a parallelogram. So let's do that. The slope of anything is y1 minus y2 for x1 minus x2 m. So let's try that with DC right now. So the slope of DC will be equal to 7 minus 5 over 8 minus 4. That equals 2 over negative 4. Simplify, it's going to be negative 1/2. So this is a slope of negative 1/2. Switch colors. Let's try AB, which is its opposite side. That's 1 minus 3 over 2 minus 6. That's negative 2 over negative 4. So this is going to be 1/2. Now I made a mistake here. I said negative 4 here when it's obviously 8 minus 4 is positive 4. So this is actually positive 1/2. I made a mistake. So this is actually positive 1/2. Whoops. And so this is also positive 1/2. And now, as you see, DC and AB both have the same slope. So therefore, DC and AB are parallel. Okay. Now let's switch to a lighter color here and try the other pair, DA. So AD is going to be 1 minus 5 over 2 minus 4. This is negative 4 and this is negative 2. So that simplifies to 2 as our slope. M equals 2. If we want to use black for the last one, we want to find the slope of BC. That's 3 minus 7 over 6 minus 8. Again, negative 4 over negative 2. The negatives cancel out for a slope of 2. And again, these are the same slope. So therefore, AD and BC are parallel. And now we have two pairs of parallel sides opposite. So now we can write a therefore statement. Therefore, ABCD is a parallelogram because both pairs of opposite sides are parallel. Okay, so that would be your statement to show that the pairs of opposite sides are parallel. And now I'm going to get a bigger eraser. And now we know these givens. So this is now a given. ABCD is a parallelogram. I'll rewrite that. We've found this out. We've made this fact. So now I'll just erase this right here because we already know it. And now we need to know what a rhombus is. There's two ways of proving a parallelogram is a rhombus. One way is, whoopsies, not the line tool. One way is showing that the slopes of the diagonals are perpendicular, and the other way is showing that two consecutive sides have the same measure, which would mean that all four sides are congruent, and a rhombus has four congruent sides. Here I'm not going to get myself into distance, I'm just going to take slope again. But this time with the diagonals. So the slope of AC is going to be 1 minus 7 over 2 minus 8. It's negative 6, everything cancels to have a slope of 1. For dB, it's going to be 3 minus 5 over 6 minus 4, negative 2 over 2, negative 1. As you might know, negative 1 and 1 are negative reciprocals. Therefore, and I shouldn't say there, I should say AC and DB are perpendicular because their slopes are negative reciprocals. So therefore, since we know that their diagonals are perpendicular, which is a characteristic of a rhombus, we can now have our big therefore. ABCD is a rhombus because, and then I hope that you are able to fill in this blank. Now we go one tier higher. We have to prove that something's a square. So I'll write this out really quick. These are the coordinates of another quadrilateral. Please hold while I draw this as fast as I can. L, U, C, K. We need to prove it's a square. If you remember our hierarchy, parallelogram at the top, and then it splits into rhombus or rectangle, and then it converges to a square. So you can take many routes. You can go parallelogram rhombus square, or you can go parallelogram rectangle square, but you need to prove either rhombus or rectangle first before you try and prove a square. But first we know that the first step is given. We need to prove it's a parallelogram, so let's do that. We can do that with slope. So let's take the slope of KL, and that's 3 minus 1, negative 1 minus 1, 2 over negative 2, negative 1. CU this time. That's 3 minus 5 over 3 minus 1. And that's negative 2 over 2. That's again negative 1. So since they're the same slope, we can determine that these two sides are parallel. Switch to red. Let's find out KC. KC is 3 over 5 over negative 1 minus 1. So that's a slope of 1. And LU, 3 minus 1, 3 minus 1, 2 over 2, also equal to 1, and they have the same slope, so these are also parallel, and we have two pairs of parallel sides. Therefore, luck is a parallelogram because blah, what I wrote already in the previous problem. Now we have to make a decision. Do we want to prove it's a rhombus or a rectangle? Well, we already have these slopes for KL, which is 1, and LU, which is 1, and CU is negative 1, and KL is negative 1. Now, if you might notice that CU and LU and all these, the vertices, are right angles, and that's because the line segments are negative reciprocals. 1 and negative 1 are negative reciprocals, so that means that these line segments are joined together at right angles. They're perpendicular to each other. So we know that right from just doing a parallelogram proof, we already have proof to make this a rectangle. And so therefore luck is a rectangle because it has one right angle, and then you could show the work that 1, negative 1 are negative reciprocals. So let's just do the distance formula on KL and LU to double check this. So KL distance formula is going to be negative 1 minus 1 squared. So that's rad 8 over here, rad 8. And now we're going to do LU, which is square root of 1 minus 3 squared plus 1 minus 3 squared, 8. So we see that there's two consecutive sides, and that means that all four sides have consecutive sides. So this is also a negative rad 8, this is rad 8. So each of these are congruent. Here, sorry, wrong color. Here congruent, here congruent, here congruent, here congruent. So now you can say that luck is a square because all sides, well, two consecutive sides are congruent. So that was a long one, but you see where I'm going here. I first proved it was a parallelogram, then I proved it was a rectangle, and then I used properties of a rhombus to prove it's also a square, because both a rhombus and a rectangle have to be a square. If I want the rhombus path, excuse me, if I want the rhombus path, I'd still have to prove it's a rectangle, use the properties of a rectangle to prove it's a square. You need both a rhombus and a rectangle's properties to prove something's a square. Thanks for watching.